friends, so this time I am back with one new question of the circle on SEE theorem. So here's the question. In the figure, O is the center of the circle. Here is given one figure where O is the center of circle and DO is perpendicular. This DO is perpendicular to AB. It seems like it is not perpendicular, but in the actual figure it is perpendicular. I made this. That's a little bit. DO is little bit slanted to make acute angle, but you have to suppose that it is perpendicular. Then we have to prove that AOCD, these are concylic points. Concylic points means the vertices of the cyclic equalator. Concylic points are those points which lie in the circumference of the circle. Though here is D is out of the circle, but here may be another circle, another big circle which touches this whole AODC imaginary another circle. So let us start the question. Given O is the center of circle. To prove same it is in the question. Now we have to do one construction. Here we have to prove that AOCD are concylic points, or simply AOCD is cyclic equalator. That's why to complete equalator, one side of the equalator we join AD, therefore AOCD here becomes one complete quadrilateral. Now let us start in the proof section, statements and reason. Now what we will do is we will compare this to triangle ACB. You see this triangle ACB, this triangle. I will highlight it by little bit red one. ACB, this triangle, and this triangle. We will compare this. We will compare this triangle, and from here we get that. Look, this angle is 90 degrees. It's already given in the question. Because DO is perpendicular to AB, and this angle must be 90 degrees because it is the angle made by the diameter. This AB is diameter, and when the opposite ends, when the ends of diameter are joined, it makes angle 90 degree at the circumference of the circle. So here makes 90 degree. That's why 90 90 they are equal. Same thing is written in ACB. ACB, this angle is 90 equals to DOB. DOB is given in the question. Both are 90 degree, and we see that this is common for ACB also, DOB also. That's why common angle. And when two angles of circles are equal, then third angle automatically becomes equal. Why? Because the sum of three angles of a triangle is 180. When two angles are equal, then third must be equal, and without third equal, the triangle is not possible. So from here we get that this angle, let it be A. Okay, let it be A. This angle equals to this angle, let it be A. We get the conclusion this from this statement number 1. When this angle is equal, these two angles are equal. Look, they are standing on the line segment OC. This is a line segment OC, or simply it is the radius for the circle, but it is one of the line segment. So the angle made by line segment on the opposite vertices of a quadrilateral are equal. Angle made by the base on the opposite vertices of the quadrilateral are equal, and these two is joined, means AOCD must be cyclic. This property of cyclic quadrilateral we have already learned. That's why AOCD is cyclic. Statement 1, in statement 1, angle made by the line OC are equal. Line OC, base, or you can say any types of line segment. That's why if they are cyclic, means AOCD is concylic points. Now we got one. We got next what we have to prove the OCA. This OCA sounds like this angle. This angle equals to ODB, this angle. Now how to prove that? Look, OC is radii of circle because it is center and it is any point on circumference, and Y is also radii of circle. This radii of circle are always equal. Here forms AOC. It seems like isosceles triangle, and it is isosceles triangle. The isosceles triangle base angles are equal. If it is A, this is also A. Then this equals to this. Because now you see here CAB, this angle equals to this angle. Why? Base angle of isosceles triangle is OC equals to OA. This OC equals to OA. Now in statement 4 we can directly add compare statement 3 and statement 1C. Here CAB equals to ODC, CAB equals to OCA. Now we can remove these two and we can write ODC equals to OCA, OCA equals to ODC, means from statement 1C and 3. So this we have to prove, and this is also proved. So thank you friends, this was one of the amazing question we solved. On which question we have to make next video. Don't forget to comment and as well as like, share and subscribe as well.